This conference will now be recorded.
Hi, I'm Vilvamani. I'm working as a cloud solution architect as well as a DevOps engineer in Accenture Solution Private Limited.
Mm-hmm.
Okay, first thing is in agenda of the DevOps, first thing is software development life cycles. Do you have any software development life cycles? Do you know what are the software development life cycles we are using?
No, I'm not using because sir, I didn't work in any software companies till now. I was in a teaching line, so I theoretically I know that SDLC was there.
Okay. This is our traditional SDLC. In our traditional SDLC, what they will do first, the customers and then development team will sit and then they
Hmm.
will collect all the requirements and then they will shape the requirements
Hmm.
based on the client needs and then they will do the sign off. After once the requirement is signed off, then the planning stage will come. That
Hmm.
they will plan what technology we are going to use and how many members we required for this development purpose, and then how much duration it is needed, and then budget. Those kind of stuffs they will discuss. Once the planning is also signed off, then they will go to the design phase or development phase.
Okay.
Once the design is over, at the end of the if they develop the products, they will go for the build. In during
Hmm.
that build, we will get a lot of bugs and integration issues. Those and all started in the test phases. Once all the issues are sorted out, then it will move to the testing phase. There they will do all the functionality testings. Then they will deploy the applications in the customer end. Customer will do the multiple round of testings like user acceptance testing, member acceptance testings, and then performance testings. Those kind of steps they will do. After that only it will go to the actual production environment.
Okay.
But now the recent trend is we are using a agile based software development life cycles. In agile based software life cycles, we have a terminology called a sprint. It is nothing but a short durations. It is either 2 weeks or 4 weeks. It depends on the clients. The period is vary. Within the 2 weeks or 4 weeks period, we have to deliver minimum working protocols, not the complete software, but single model of that complete softwares we have to deliver to the customers. Before
Hmm.
that, we will accept that these are the here the requirements. They call it as a stories. They will accept these are the stories, and we need these many resources. And for each story, they will assign a story points. They will assigning in a Fibonacci series 1, 2, 3, 5, 8 like that.
Hmm.
Based on that complexity, the number will be increased.
Hmm.
Okay, here what they will do first, they will accept the story points, and then multiple developers will work together, and then they will develop the products, and then they will do the integration testings. Okay,
Hmm.
and then within a time period, if examples, if you're doing some development for 1 hour, all the developers will push the code after 1 hour.
Hmm.
The automation tools will pull the code and it will do the build and it will do the integration test, and then it will give the feedback to us, so that it will be easier for us to fix the issue earlier.
Hmm.
In the traditional models, uh, the build will happen in the night, and next day only we are build will happen night, or sometimes based on some projects they will do the build every 1 weeks or 1 month, like that they will do. At the end of the build only we are able to know what are the issue, integration related issue is there, and functionality related issue is there. So it is we'll get the feedback very later, whereas in agile we'll get the feedback very faster. And once, if you see this one, the development cycle will happen for uh, 2 weeks, and then they will review the functionality, and then they will
Hmm.
give the feedbacks. If the
Hmm.
customer approve that is the product owner is the customer here. If they approve the requirements, it will go to the deployment. If they are not approve the story, again it will come to the next iteration. That is the same activity they will do again.
Yes, sir. Yeah.
Coming to DevOps is nothing but it is a collaboration between the development team and the operation teams. The development team has to know what is happening in the operation, and the
Hmm.
operation team has to know what is happening in the developments. Without their collaborations, we can't deliver the products as soon as possible.
Hmm.
And also in some scenarios, QA will also, if you see this slide, we have development, we have operation teams, and then we have a quality assurance team also. All
Yes.
together is called a DevOps. Now they have another terminology called DevSecOps. It's nothing but they will integrate a security also along with this. Whatever security gaps we are having in the DevOps, that has been filled by DevSecOps.
The DevSecOps. Okay.
Yep.
Hmm.
And this is how the development team will do. They will develop the products, and then they will do all the documentations, and then they will do the bug fixings. This is general about development team. And in operation teams, again, we have multiple peoples. We have server management teams, and then application management team, database teams, network teams, security teams. All together they will do various tasks in DevOps. Both the development team and the operational team will collaborate, and then they share their works, what they're going to do and how they're going to approach. That is the main thing will be applicable in DevOps.
Hmm.
If you see in quality assurance, we have this do plan check act. What they will do, the quality team will plan how many test cases we have to create for this particular story points, and then they will do the actual task, and then check whether the activity is passed or not. If it is passed or failed, based on that they will act what action next they have to do.
Hmm. Right.
And this is again general information about DevOps. And
Hmm.
SDLC scenario, we have some issues in our software development time cycle. Developers will spend 70% of their timing in the waiting. The reason why is, if I'm creating some code, I have to know whether my code is working fine along with your code. So I have to wait until the deployment is happening. So my 70% of the time during the product development will be in a waiting state. And test like that, the testing team is also has to wait until the development team has to complete their they have to develop the full products, and then they will started doing this manual testing. So there also they have uh, waiting times. And then infrastructure, sometimes the infrastructure is not available, so for that we have to wait. And then we have our ops support team has to be there, application related things. And then labs, we have a lot of complications in traditional SDLC scenario.
Hmm.
DevOps is a solution for that. Since the development team and operation team is working together, what they did the automation, infrastructure automations, and they do build and release automations, and they will going to deliver the product in a short time, that is 2 to 4 weeks. So it will be we can easily find the bugs, and then we can fix as soon as possible.
Hmm.
This is the main goal of DevOps. One is increasing the agility and increase the quality, improve the innovations. We have to daily basis. We have to do some innovations in the DevOps. We can invent new innovations, and when we're doing this, all these things, our time will be reduced 80%. We can deliver the products as soon as possible. We don't need to wait for a long time.
Hmm.
Again,
So,
DevOps.
excuse me, sorry to interrupt you,
Yep.
but this a PPT or some material will be available for me for study, so later on I can, in my spare time, I can brush it up again.
Yeah,
So,
sure. I will share this PPT with you.
okay.
Along with this, I have for one more PPT I'm having with related to source code management systems. That also I
Hmm.
will share with you.
Okay, no problem, no problem.
Yep. Again, we in DevOps we have some jargons like continuous integrations, continuous delivery, continuous deployment. Continuous integration is nothing but multiple peoples are working together. They will put their code in central source code management systems. From there, some tools will pull the code, and then it will do the build and unit testing, performance testing. We have multiple stages. The stages will differ based on the clients or based on the projects, how we are working. So after that, we will get a frequently we will get the feedback on our continuous integrations,
Mhm.
and this is the continuous integration architectures. We have a development team. The development team will write a source code and then they push into the source code management systems or version control systems, and the
Mhm.
source code build tool is used to they will build the source code and then they will do the analytics, source code analytics, either any coding standard is not followed or not, and then we will run a automation unit testings, and then based on the unit testing we will do a code coverage analytics, how much code has been covered during this unit test case. That is, if examples we have a if else statements, whether my unit test case was covering both if and then else conditions, whether my application is working perfectly or not. And
Mhm.
then this code coverage is completed, it has passed this code coverage. In some scenarios they will set this code coverage as 100 percentage, in some projects they will set 80 percentage. Once it is past that scenario, our our source code, that is our binary class binaries, are pushed into build artifacts, and then from artifacts they will push the code, and they pull the code, and then they put it they will do the deployments, and then we will run the automation functionality testings, and then it will produce the report. Again the same cycle will be repeated in the continuous
Mhm.
integration.
Mhm. Got it.
These are the benefits: saying goodbye for long and tense integrations, and increase the visibility, enabling greater communications, because we are giving a frequent feedback to the customer, to the development team and testing team, that these functionalities are failing, and these are the code which having a build issue. Like that, we can give faster communications to them, and spend less time on debugging and more time on adding a features. Since
Mhm.
if we are having a huge amount of code, in that time it is difficult to analyze where exactly my code is failing. When we having a shorter code and it is tested fully, so that we can easily identify the bugs in our code, and it will build a solid foundations. These are some of the benefits in continuous integration.
Mhm.
And coming to continuous delivery is the ability to get changes of all the types. Sometimes the user will, for this sprint, they will give some requirements. In the next sprint, there is some slight or major modifications in that requirements. We have to accept the changes and then we have to do. But whereas in our traditional software development life cycles, it is difficult to accept the changes during the development process. Either we have to do the complete development, and during a maintenance only we will accept the new changes. But in whereas in agile we have to accept the changes, we have to ready to accept the changes, and we have to implement those things, and we have to deliver the product as soon as possible to the client.
Nice. Yes.
And when we delivering this is the benefits when we delivering the small working prototypes to the client, it will reduce the development risk, and also we will get a timely feedback from the users whether we have to improve anything, or we are going in a right manners, and we can
Mhm.
track the progress also, how we are going and how much
Mhm.
time it will take to finish the complete activity.
Mhm.
In continuous deployments, we will do the deployment in multiple regions, like testing, uh, UAT, MAT, production, pre-productions, like that. We'll do it in a continuous different places. It's called continuous deployments. And we have benefits also there, since it is automated, we no need to worry about the configuration changes. And this is the
Mhm.
main difference between continuous delivery and deployments. Whereas in continuous delivery, we will do the production deployment manually, whereas in continuous deployments we will do everything in an automated manner.
Mhm.
And
Mhm.
when the recent times we are hearing this jargon also, microservices. Microservices
Mhm.
is nothing but it is a small part of the applications. It will work independently with any models. We can communicate from any front ends. For example, if you take the banking transactions, uh, we can go and do the transactions using a particular bank account, or we can do it from Paytm's, WhatsApp, because we are doing from the multiple places. But the final goal is we have to transfer the money from one account to another account. For that,
Mm-hmm.
we are using this kind of microservices. It's nothing but application programming interface. Uh, we don't have UI for this microservices. It is deployed in a particular place and it will communicate with the backend. And we have some contract between the UI and then this microservices. Whoever having the contract, they can communicate with our microservices, and then it will do the handshake, and then it will do the actual activities.
Mm-hmm.
And next thing in DevOps is infrastructure as a code. Instead of sitting for hours to develop our infrastructures, we can write a script to automate the infrastructures, server creations, everything we can do it through a code. We no need to do it through a UI or uh, doing other stuffs.
Mm-hmm.
It will reduce the system administrator time also, and we can do that. We can create the infrastructures within a minute. It is based on how complex our infrastructure. If it is a complex infrastructure, it will take some 20 minutes or 30 minutes. If it is a simple infrastructures, it will take some 2-3 minutes to do the DevOps activity.
Mm-hmm.
And these are the tool chain we having in a DevOps for code commit. We are using Jira. Jira is used for creating stories, that is client requirements, and to track the bugs in Jira. And we are to save our source code, either it is Java or .NET or Python or PHP, whatever language. We can go and save our source code in JIT and SVN. These are some of the famous tools in source code management. For build, we are using Apache and Maven and Gradle. These are some of the build tools, and we have 100+ build tools also. These are the common build tools which is used in a Java-based developments. And we have
Mm-hmm.
a Selenium automation testing and JUnit automation testing for Java, and we have MUnit automation testing for .NET. And for release purpose, we are using Jenkins and Bamboo. These are some of the famous tools for continuous integrations and deployments. For monitoring, we are using Nuggets and Spank, and we have some SUSE products, some other products also, and New
Mm-hmm.
Rally. These are some of the monitoring tools. Depends on the clients and the products which we're using. The tool will change. These are the common tools. It will come when we speaking about the DevOps tool chains. And for deployments, if it is a configuration management, it is a automated configuration management. We can use a Puppet Chef for Ansible or StarStack. These are some of the configuration management tools. Okay, we no need to worry about the production deployments and the testing deployments. Everything will be configurable. We have to put our source code, and when you're executing this configuration management tools, it will go and install at a particular region based on the environment which we configured already.
Okay. Sir, shall I ask you a question?
Yeah, sure, sure.
Okay. You say that we do our story in the Jira and we store our coding stuff in a Git, right?
Yeah.
So, in a whole DevOps, how much I have to focus on the code, or and second question is that first of all, do I need to have already a knowledge of Java, PHP, or JavaScript, anything else?
Okay, coming to this one, if you are if you are planning to looking at development based jobs, in that case you
Mm-hmm.
need the development knowledge, a
Mm-hmm.
complete knowledge about the language, either it is a PHP or Python or Java. If you are
Mm-hmm.
looking only at DevOps related solutions, okay, in that case you no need to worry about the Java. The basic knowledge you need: how to compile a program, how Java is compiled, how .NET is compiled, and how
Mm-hmm.
PHP is executing, and where it is executing. Those kind
Mm-hmm.
of knowledge alone we need. For DevOps person, that operation person, they want that things. For development, if you're from a development background, in that case you have to learn the language completely. For developer DevOps perspective, you no need to know everything, but you want to know how Java is working and what are the places it's working on, what are the frameworks available in Java. If you take Java, we have core Java, and then we have a J2EE concepts, and we have a JSP concepts, and we have Spring Boot, Hibernate, Stacks, and then like that we have different frameworks in Java. So the client or the development team, what framework they are using, where their application is going to run. If it is a Spring Boot application, Spring Boot itself is having an internal Tomcat which will run independently. If it is a
Mm-hmm.
JSP based applications, we have to we have to create a var file, and then we have to deploy that var file in Tomcat or WebLogic or WebSphere. Like that, we have to know all the tools. What are the possible tools used for Java, and what are the possible tools used for .NET? Those kind of stuff we have.
Yeah, so the basic things I know about every language is Java, JavaScript, and anything else fine. But I don't have that much knowledge of coding, and I'm not from the development
It's
background.
not required, but when you coming to DevOps, you have to learn some other additional languages like Ansible. Okay, Ansible is it is based on YAML. If you're interested to learn Chef, in that case you have to learn Ruby, and Python is some places Python is required. And when we're going for Jenkins, that case we have to learn Ruby. Again, it is a simple language only. It is very straightforward. Maybe Ruby is bit difficult, whereas the YAML is very simple language. And if you take infrastructure automations, we are using a Terraform. That is also very. It's like our English language. We have some variable, and for that variable we have to fill the values. I'll show some examples to you.
Okay, no problem, sir. And the Ruby and all the those coding part which are required in the DevOps will be covered in the training session or not,
I'll tell what are the tools I'm covering and what are the languages required for that.
sir?
I'll tell
Mm-hmm.
you that one.
Mm-hmm.
Once after all this PPT is over, I'll say what are the tools that I'm covering in this course, and then what
Mm-hmm.
are the languages preferred for that part.
Mm-hmm.
And the role of DevOps engineer, if you see, they have to do the automations in an effective manner, how fast we can deliver the product. That is the main intention of DevOps engineer.
Mm-hmm.
And these are the cultures. If we have a claims framework is culture. We have to share our things with others, and then we have to learn new things. Again, when we're learning, we have to share with the peoples, and the automations and measurement, how fast we can create a disaster recovery environment. Those kind of stuffs available in the DevOps framework.
Mm-hmm.
And these are development team challenges: the waiting time for code deployments, and the pressure of work on the old and pending and new codings. This has been resolved by DevOps using a continuous integration solutions, and they
Mm-hmm.
no need to wait. Once they commit the code into, that is, once they save the code into the source code management systems, it will automatically pull the code, and then it will do the integration.
Mm-hmm.
So that way we can do the things. And these are again another challenges: complex of pre-production, production, build and runs, and then inefficient and complex error preventions and diagnoses, standalone setups and narrow thinking, increasing rate of challenges versus stabilities. This is a change by the change cultures, one deployments to operation life cycles, and common tools we are using, so that we can overcome these challenges. And these are the operational challenges: difficult to manage the uptimes of production environments, and tools to automate the infrastructures and managements are not effective. Number of services to be monitored increase every days, and difficult to diagnose and prevents the feedbacks on the productions. This uptime is we can create a virtualization environments to resolve these issues. For tools automations, we have a continuous management tools. Using that one, we can automate everything, and we have a continuous monitoring tools to monitor services. And these are the problems. If you take a DevOps, using a DevOps, Amazon, every 1 minute they are deploying more than 1,000 services in their production environment.
Mm-hmm.
And a better deployment quality, we can increase
Mm-hmm.
33% and fast release frequently and improved process visibilities. Everything is transparent in DevOps here. For meantime between the deployments, big days it is between two deployments, the time frame is 11.6 seconds. For every 11.6 seconds they will do a deployments, and maximum deployments is number of deployments in a single average is around 1,000 plus deployments, and they're doing more than 10,000 simulations repeatedly, and maximum servers they have is 30,000 plus servers they're having in their production environments.
Mm-hmm.
And these are again, when you're going for DevOps approach, we have some benefits. And these are some of the companies they're using DevOps very effectively and frequently. Amazon is doing 23,000 deployments per day, and Google is doing 5,500 plus deployments per day. And again, Netflix, they're doing a 500. Facebook is every day they are releasing features in Facebooks, and they're fixing bugs in Facebooks. And Twitter, weekly they're doing a three deployments, and others we having they are using frequently.
Mm-hmm.
And again, we have this is a tool set, Agile plus DevOps tool set. What are the languages we're using along with this? If you see this one for source code management, either we can go for Mercury, Git, or Subversions. For continuous build, we'll use a Maven, Ant, or a WSO2. And for continuous integrations, Jenkins is Bamboo and famous tools. For automation, we have Selenium, JUnit, Sonar, those kind of stuff. For continuous deployments, we are using Docker, Puppet, or Chef, Ansibles. And project and management teams, we are using Jira or Rallies. Software development workflows, for that we are using again WSO2, uh, Jira, Agile we are using. And for development code we are using Eclipse, Circular, TFS, like that. We have different tools for Agile and DevOps combinations.
Mm-hmm.
And now actually this is old statistics. Now most of the projects are implement this DevOps. They adapted with the DevOps, and they're delivering the products in agile based. Non-agile, still in non-agile projects also they're using a DevOps, but their development delivery frequency is less, whereas in agile we will deliver the product very frequently.
Mm-hmm.
And this is the difference between the DevOps and agile based developments. In agile we have iterative developments, and we have scrum, sprint, and stories and velocities. In DevOps we are doing continuous integrations, continuous developments, IT automations, and application managements. Again, this is some difference. So far, any questions in DevOps?
Yeah, actually, I was clear with the language and okay, fine. Yeah,
Okay,
practically I also
okay.
get.
Then what I'll do, I'll go and explain what are the tools we are going to see it in a DevOps.
Mm-hmm.
Okay, first one is source code management system. In source code management system, we are going to see JIT. Based on JIT, we will see a cloud repository, JIT Hub, and Bitbucket. These two tools we will see for
Mm-hmm.
continuous delivery, continuous integration, and delivery tools. We'll, we'll see Jenkins. For this, we need a language that is the basic understanding about Groovy. Okay, it is very simple language. We have a generator for that. Using the generators, we can generate our stuffs. For few things alone, we have to do it in our manual stuff. And next thing is Docker. It is a containerization orchestration tools. Uh, examples, it is a replacement of virtual machines. The reason why is the virtual machine is running on a separate guest operating system, whereas Docker is running on the host operating system. That is in our actual operating system, Docker will run. And the fourth thing is continuous configuration management tools.
Mm-hmm.
So configuration management tools, I'm teaching Ansible. For this, we need YAML language we are using. Again, it is a very straightforward. It is like a English. For Ansible, we need and Linux admin skill. Okay, because nowadays most of the servers are running based on Linux operating system
That's
only.
right, right, right,
So
right.
we need a basics understanding about the shell scripting. That then
Mm-hmm.
Ansible is very easy for you.
Mm-hmm.
And the fifth one is we'll see Kubernetes. We'll see Kubernetes or OpenShift basics, how to create an infrastructure
Mm-hmm.
using Terraform. These are the main things we are going to learn here. Okay. Uh, Here in continuous integrations, again, we will use some other tools like Ant, Maven, Sonar, Cube, JUnit. These
Mm-hmm.
are development tools. We need a basic understanding about these tools, what these tools is doing. These
Mm-hmm.
things we have to learn. We don't need to learn Ant completely, but we have to know what is Ant and for what purpose they are using. And we have to know what is Maven and for what purpose they're using Maven. Like that Sonar Cube. Sonar Cube is again source code analytics tools. It will tell whether we are following any following the coding standard or not. Those kind of stuff will save it in a Sonar Cube. And then we have JUnit for unit testings, and then Selenium for automation testings.
Mm-hmm.
But we are not going to learn Selenium, but we will use some sample model from the GitHub, how the Selenium is working. Those kind of stuff we will see.
Mm-hmm.
And if you want the complete course details, I'm having. Okay, first we'll start with basics Linux, and then whatever introduction we saw, those things, and then we'll see about the basic introduction about cloud computings and JIT, that is source code management systems. In
Mm-hmm.
source code management systems, we'll see how to install a JIT and what are the how to create a repository branch and how to merge two branches. Those kind of
Mm-hmm.
stuffs we have learned it in JIT. And coming to Jenkins, we'll see about continuous integration overview and how to set up Jenkins and how to run. We have various installation methodology in Jenkins. Those steps we will learn. And configuring Jenkins, we have to configure the tools in Jenkins, and we'll see how to configure those tools. And working with Jenkins build, and then working with automation testings, here we'll see JUnit and Maven testings, and we have some advanced concepts in Jenkins that also we'll see. And what are the plugins we having, the frequently used plugins, those plugins we will see. And security related stuffs we'll see it in a Jenkins, like user creations and providing access to the users. And we'll see server client configurations also. Since we if you take Amazon, we saw that in Amazon they are running 23,000 build per day. All the
Per day, yes, yes.
23,000 build, we can't do it in a single systems. So we
Mm-hmm.
need a architecture like master and slave configurations. Uh,
Mm-hmm.
one at masters at one place. The master will create a job there and will master will say, schedule the things that this job has to run on this particular slave and this job has to run on this particular slave. Those kind of architecture also will design in Jenkins. And coming to Docker, we'll create a Docker sample Docker image, and then we'll deploy it in Kubernetes or somewhere else, and we'll do how to do the basic networking stuffs. Those kind of stuffs we can see it in a Docker. And coming to Ansible, again Ansible installations, and we have an inventory, Adobe commands executions, playbooks. We can use a templates and Ansible facts, Ansible roles, Ansible Galaxy, Ansible Vault, and then basics introductions about Ansible Tower. It is an enterprise tool. We'll see about those things also, and we will see basics of Kubernetes or OpenShift. If you want, I can show some sample again. Okay, last week for one of the interview, they give this scenario. We have to create an automation infrastructure. We need a three servers. In two of the servers, we have to deploy a web servers, and one server we have to put a load balancer. Using this load balancer, we have to uh, split our load into these two systems. We have to do this in an automated manner. For this, the company recommending to use these tools for virtual. We can use VirtualBox and then Vagrant. Okay, using these tools, I can provision this in infrastructure within 15 minutes. I don't need to spend much time. Just I'll run a single command. That command will go and do all the stuff. First, it will create a server in the VirtualBox, and then it will deploy the application in the VirtualBox, and then it will deploy my application also in that particular VirtualBox. When we doing the curl, it curl to this load balancer, it will automatically send my it will split my request to this two servers. These are the basic stuffs about the DevOps. This is the and the organization is also expecting this basic things only. Again, we have advanced tools, and depends on organizations. The tools will differ. If you see in continuous in source code management tool, some companies will use Bitbucket. Some if Microsoft related product, there they have something called TFS, Team Foundation Server. In Team Foundation servers, we have the complete things. We have a Jira with the Team Foundation servers. We have .NET frameworks. We have a Microsoft SQL Server. We have for similar to Jenkins in TFS, we have a tools that is continuous integration, build tools, and all the stuffs we are available in TFS. Like that, some company instead of Jenkins, they will use a Bamboo, and Docker is the only containerization technology. It's a famous containerization technology. We have a LX Linux container platform, but that is not that much famous. Docker is the famous one for continuous management tools, configuration management tools. Some company will use Chef, and some company will use Puppet. Like that, it depends on the company. They will use different tools. And if you see, one of my client is using Kubernetes, other client is using OpenShift, and some in AWS we have Amazon Cloud and Azure. We have this Kubernetes as a service, as well as Amazon have their own product called Elastic Container Services. It depends on client and their budget. They use a different tools. The basic understanding is this one. Source code management, we need one tool we have to know here, and we have to know what other tools is having, so that if you're strong in JIT, they will consider that okay, if I assign you in the SPN, there also you will work. The commands and all are similar. The way it is working is different. Like that also, again CI/CD, Bamboo and Jenkins is going to do the same work, but the thing is, at the end of the day, the work is same, but the tool is different, and the way it is working is also a little bit different. That is the main info. This is a basic course about the syllabus about the DevOps. Once if you enter into the organizations, there based on the organizations, you learn other DevOps tools.
Okay.
Okay, Krupal. Okay, I'll share
Okay, sir.
the PPT with Manivandan so that he will share with you.
Okay, no problem, sir. Yeah,
Any other
because
question, Krupal?
if I'll get the material, some reading material, so the whole day I am free, so I can learn it and brush it up
Yeah,
properly,
I'll
sir.
share this PPT. I'll share this PPT with Manivandan. Just you go through the PPT, and if you have any doubts today night IST time or tomorrow morning is not possible. I have some personal works tomorrow and day after tomorrow. I'm going out. Anyway, just we will discuss. Otherwise, we will discuss through the conference call if possible.
No problem, sir. No problem.
Yeah. Thanks, Krupal.
Okay. Okay. Thank you very much, sir. Okay.
Thank you. Bye.